Hello, today we're going to be talking about Fundamental Theorem of Calculus Part 2. Now Part 1 concerned the derivative of an integral, so you might guess that Part 2 concerns the integral of a derivative. So if I integrate a function, and capital F is the antiderivative of function f of x, then this will be capital F of b minus capital F of a. Now this basically looks just like the the definition of a definite integral, and yes, that is one of the things that you can do with it. But there are two specific problem types that you're going to be using Fundamental Theorem of Calculus 2 for. So one is for if you want to define a function in terms of an integral of another function, and you know one point for that function. So we did some problems earlier where given some function f of x, and we want to basically find capital F of x given certain information. So for example, let's say capital F of 3 is 5. What we can do is we can set up an integral of lowercase f using a different dummy variable, because if our bound involves x, we don't want to use x here and here. So we always take as our bottom bound the x value for which we're given the specific point. So we'll put that as 3, and our top bound will be x if we want capital F of x. So from 3 to x, this, by Fundamental Theorem of Calculus Part 2, will be capital F of x minus capital F of 3. Because capital F of 3 is 5, we substitute that in. And so if we want to solve for capital F of x, we just subtract over that 5. So this is how you define the function in terms of x given the integral of its derivative. You can also do this for like specific values. So let's say we knew what a particular let me rephrase that. So the other way you're going to do this is you're going to solve for the antiderivative at a specific value given it at a different value, as long as we have the graph or the function of its derivative, lowercase f of x. So typically this will be on an FRQ problem. Let's say I had something that looked like this. So let's say we were given that this is the graph of the derivative of x. And we know that f of 0 is equal to 7. Notice that it's not 2, right? That's what f prime of 0 is. F of 0 is 7. So this would be some piece of information we're given. And we want to figure out what f of 4 is. What we would do is we would apply Fundamental Theorem of Calculus. So the integral of the derivative from whichever one of these is lower, the one that you are given and the one that you are looking for, of the derivative will give us the function at 4 minus the function at 0. We know what the function is at 0. It's 7. This is just the area, or the definite integral of this curve, which would be the area under the curve here. So we would use geometry in this case. This is we would be told this is a semicircle, and so the integral from 0 to 4 would be this area, so 1/2 base times height for this triangle portion, and then the area of a semicircle, radius 1, from 2 to 4. We then solve for f of 4. So that's going to be a 2. 2 plus 7 is 9. And so that will be f of 4. So those are the two main ways that you're going to apply Fundamental Theorem of Calculus Part 2, other than just doing definite integrals. Hope that helps.